The topic for Lesson 3.6 is ratios and proportions. You'll determine whether two ratios form a proportion and solve proportions. An example of how ratios are used in recipes: the ingredients in the recipe will make 4 servings of honey frozen yogurt. Carrie can use ratios and equations to find the amount of each ingredient needed to make enough yogurt for her club meeting. A ratio is a comparison of two numbers by division. The ratio of x to y can be expressed in the 3 following ways. Either we can write the word to, we can use a colon like we did with odds, or we can use a fraction bar like we did more often with probability. An equation stating that two ratios are equal is called a proportion. So we can state that 4 over 2 equals 8 over 4 is a proportion. There's 2 ways to check to see if ratios form a proportion. The first way is to see if they form equivalent fractions. So if I take 49 over 56 and I divide by 7 over 7, I get 7/8. So I know 7/8 equals 7/8. So these two would form a proportion. The second way we can check if two ratios form a proportion is by using cross products. So we could write 0.25 over 0.6 equals 1.25 over 2, we hope. When we do cross products, we take numerator times denominator, and we hope it equals numerator times denominator. They call one of these is the means, the other is the extremes. We'll get those defs in a second. So in our products, 0.25 times 2 is 0.5, and 0.6 times 1.25 is 0.75, which they are not equal, so these two do not form a proportion. Now for part B, if I check 4/5 to 16/20 using cross products, numerator times denominator, that's going to be 80, and numerator times denominator is 80 again. That is a true equation, so yes, that does form a proportion. In a proportion, the product of the extremes is equal to the product of the means. So they're calling the letters in this one, A and D are called the extremes. And so that means that B and C are called the means. Now I tend to just do numerator times denominator equals numerator times denominator, but the vocabulary comes up, so we should mention it. So to solve the proportion, we're going to have the product of the extremes, so 8n equals the product of the means, so 3 times 12. So 8n equals 36. Divide both sides by 8. And it doesn't come out as an integer, but n equals 4.5. We can get decimals, it's okay. The ratio of two measurements having different units to measure is called a rate. For example, a price of $1.99 per dozen of eggs, a speed of 55 miles per hour, and a salary of $30,000 per year are all rates. Proportions are often used to solve problems involving rates. And in each one of these statements, the word per, so $1.99 per dozen. So per would be written with a fraction bar for division. The gear on a bicycle is 8 to 5. This means that for every 8 turns of the pedals, the wheel turns 5 times. Suppose a bicycle wheel turns about 2,435 times during a trip. How many times would you have to turn the pedals during the trip? If we define the variable by letting p represent the number of times needed to crank the pedals, so our proportion would be 8 turns to of the pedal to 5 wheel turns equals p for pedal turns to the 2,435 for the wheel turns. So we do cross products, and your calculator can handle the big numbers. 8 times 2,435 equals 5 times p. So when we multiply, I get 19,480 equals 5p. So divide both sides by 5, and we have p equals 3,896. If it takes 8 turns of the pedal to make the wheel turn 5 times, 8 divided by 5 would be 1.6 turns of the pedal to make the wheel turn 1 time. So if the wheel turns 2,435 times, then there are 2,435 times 1.6, or 3,896 turns of the pedal, so our answer makes sense. And now, of course, the real question is who would ask the question, but the textbook did, so we answered it. A ratio or rate, called a scale, is used when making a model or a drawing of something that is too large or too small to be conveniently drawn at actual size. The scale compares the model to the actual size of the object using a proportion. Maps and blueprints are two commonly used scale drawings. In a road atlas, the scale for the map of Connecticut is 5 inches to 41 miles. The scale for a map of Texas is 5 inches to 144 miles. What are the distances in miles represented by 2.5 inches on each map? They decided to let D equal the actual distance, which makes sense. So for Connecticut, our proportion would be 5, the scale, is to 41, the actual, as 2.5, and the scale is to D. Cross products, we're going to get 5D equals 41 times 2.5 is 102.5. So then to solve, all we have to do is divide both sides by 5, and I get D equals 20.5 miles. Okay, so Texas is almost the same. The only difference is instead of 41, I have 144. So 144 times 2.5 is 360. And then we could divide both sides by 5. And I get D equals 72 miles. Everything's bigger in Texas. So summing it up, the actual distance in Connecticut, represented by 2.5 inches, is 20.5 miles. And the actual distance in Texas, represented by 2.5 inches, is 72 miles. So if we look at it, 2.5 inches is half of 5 inches. So 2.5 inches represents half of 41, or 20.5 miles in Connecticut, and half of 144 is 72 miles in Texas. So the answer makes sense. A ratio is a comparison of two numbers by division. A proportion is an equation stating that two ratios are equal, and a proportion can be solved by finding cross products. So if A over B equals C over D, then A times D equals B times C.